Good morning, ladies and gentlemen, and welcome to the scientific part of the second AstraTech World Congress. We have several distinguished speakers this morning who are going to cover different aspects of implant dentistry. I will be the moderator for the session and also present to you some aspects of the AstraTech implant system. So I'm going to talk about the BioManagement Complex, which is a coin term for various aspects of the AstraTech system. It is a term used to emphasize that AstraTech implants allows biology to work in the favor of the dentist who is using the system. We're now going to provide you with some important features of the system. Let's start with the implants. And as you can see on this slide, there are two types of implants. The straight cylindrical one and the conical cylindrical one of an ST configuration. All these currently available AstraTech implants have an internal hexagonal interface in order to prevent rotational movements of the abutment. The first abutment that was introduced with this system was the so-called uni-abutment, which had the unique feature of meeting the inner portion of the fixture in an oblique manner. And the angle between the meeting points or meeting surfaces and the outer portion of the implant was 11 degrees. With this angulation, you get a very, very tight fit between the abutment and the implant, which doesn't really allow the development of a micro leakage. Now, this so-called conical seal design is available on all currently used abutments in the AstraTech system. The biomanagement complex has, as we can call it, four legs: the microthread, the conical seal design, the connective contour, and the osteospeed surface. I have decided in my presentation to bring the conical seal design and the connective contour into one group, and I will call that particular group the conical seal design. Let's start with the microthread. The microthread was developed by Stig Hansson many years ago, and it was based on the fact that with this microthread there should be a better retention between the implant and the bone that surrounded the metal body. The microthread implant has a knife, so it is, in other words, a self-tapping implant. The microthreaded portion is 3.5 millimeters high, but with the upper shoulder, the entire length of the upper unit is 4 millimeters. The distance between two consecutive slings of the pitch in the apical portion of this implant is 0.7 millimeter, while the corresponding distance in the microthreaded portion is only 0.23. Realizing now that the implant is cutting all the way from the apex of the implant to the shoulder of the upper portion of the implant. Now, in a study in dogs by Dr. Abrahamsson and Berglund from Gothenburg, the influence of microthread on the marginal bone level, as well as on the osseointegration, as that now can be evaluated by the amount or the percentage of mineralized bone to contact, was evaluated. Here you have two ground sections from this particular study. You can see the microthread to your left and the more old-fashioned tire-blast implant to your right. You can see in the upper portion to your left the microthreaded, and in this corresponding portion to your right there is no threaded area. Now, Dr. Berglund and Abrahams first of all studied the distance between the abutment implant junction, here indicated in yellow, and found that in the microthreaded implant this distance was 0.2 millimeters, after a period of 6 months of healing, while the corresponding distance in the traditional Tyoblast implant was 0.5 millimeter, and this difference was statistically significant. Abrahamsson and Berglund also assessed the degree of osseointegration in 2 zones. In the apical zone, where both implants had the same macro-threaded structure, and you can see that there was no difference, 83% and 84% of bone-to-implant contact. However, when they focused on the micro-threaded portion, they found that the micro-thread implant had a higher bone-to-implant contact than the traditional Tyoblast implant. And consequently, they concluded that the micro-threaded implant had a better osseointegration and more bone retention at the marginal level. In a clinical study by Dr. Wenström and co-workers, this micro-threaded type implants were studied in a 5-year prospective study on single teeth and single tooth restorations. They had 40 subjects that had been referred for the treatment, or the replacement rather, of one missing tooth. The AstraTech so-called ST implant was used. They used a 2-stage protocol according to the manual at that time: 6 months healing of the implant in the maxilla and 3 months in the mandible. And here you can see a case treated by Dr. Wenström. During the course of a 5-year program or protocol, the bone level alterations at the mesial and distal aspects of the implants were studied in radiographs. And these measurements were not made by Dr. Wenström, but were made in the radiology department of the dental school. And what you see here in this diagram on the x-axis is the bone level change. The green vertical line represents no change, and anything reported to the right means gain of bone, and anything reported then to the left means loss of bone. On the y-axis, you have the cumulative percent of implants. Now, in this particular series of dots, every single implant that was installed can be followed. And what you see here is the baseline change, or the change between baseline, which is the time of loading, and the 1-year follow-up. And as you can see, most of the dots land around the green line. In the next line, the change between baseline and 5 years is presented. And again, you can see most of the dots happen around the green vertical line. And only one implant of all lost more bone than we had anticipated. So based on all these observations, and based on similar findings by Norton, Gottfriedson, Palmer, and co-workers, we can clearly state that the microthread area, or the microthread portion of the system, facilitates retention of the marginal bone level. We then move over to the conical seal design, which in my way of thinking is maybe the most important of the various legs in the biomanagement complex. The conical seal design has platform switching, connective contour, and no contamination of the internal system as the key issues. Platform switching. Here you can see the upper portion of an AstraTech implant with the uni abutment. And this yellow line illustrates where we would like the bone level to be located. If we now draw a line between the cylindrical portion of the abutment and this yellow line, the distance is 2 millimeters. If we, however, instead follow the curvature, the platform switching, the line becomes 2.5 millimeters. Now, what cells can see, my dear colleagues, is not the line. The cells, they see a surface. And consequently, when we recalculate this, we find that with this platform switching of the AstraTech system, we have 20 to 25% more surface available for the mucosal attachment that is so critical for implant success. This platform switching is available for all currently available AstraTech abutments. Now to connective contour, and by this we mean the contour through which the implant meets the soft tissues, or how the soft tissues meet the implant. First of all, we study the profile. We understand that there is an upper cylindrical portion, followed by a conical portion, followed by another conical portion. And if we now project the soft tissue, the mucosal attachment that fits to this profile, we can see that the soft tissue takes on exactly the same profile as the implant. Now, the epithelial attachment, which is the coronal portion of the mucosal attachment, is then followed by a connective tissue attachment. The height of the epithelial attachment is about 2 millimeters, and the height of the connective tissue attachment 1.5 millimeters. This means that the biological width of the soft tissue attachment with the AstraTech system is at least 3.5 millimeters. So what is the composition of the tissues that are now facing the implant? We forget about the epithelium for the time being, and we concentrate on the connective tissue. This was studied by Dr. Moon in an animal study, where he evaluated the composition of the connective tissue in a pink zone and in a bluish zone. The pink zone is a zone very narrow, 40 microns, and the more blue zone is about 160 microns wide. Here you can see the end of the epithelium. So this is to the point where the epithelium has migrated and then stopped. And below that, down to the bone, we have connective tissue. This connective tissue has a very cell-rich zone in the pink area. And if we magnify it, you can see the dense numbers of fibroblasts that are packed in this inner zone. And in an even higher magnification, you can see again the cell-rich zone. And here outside you see a pink zone, which is actually a collagen-rich area. So if we now concentrate on the inner zone, and we magnify this zone to an electron microscopic magnification, you can see that the cells are fibroblasts, which line up in a direction parallel with the surface of the implant. Dr. Moon, he also made some morphometric measurements, and he found that in the pink zone there was less collagen, but there was significantly more fibroblasts than in the blue zone. And this observation is important because it means that the fibroblast-rich zone next to the implant surface is important for remodeling and repair of the connective tissue attachment once challenged, like for instance by bleeding on probing and probing pocket depth measurements. And you may know that in the infancy of implant dentistry, it was a no-no to probe the soft tissue because you would then damage the attachment between the soft tissue and the implant. This is no longer so, and as a matter of fact, at least in periodontology, we demand a regular probing of the interface between the implant and the soft tissue. We then move over to the contamination issue. As I told you before, there is an angulation, an oblique surface, where the abutment meets the implant. You remember the 11 degrees to the outer surface of the implant. That means that during function, nothing can come in to the internal system, and hence nothing can get out. It's an important issue here. So if we now take a profile of the abutment-implant interface here, and we study this particular zone in the attachment of the mucosa, and then we find ourselves down here.